Hi again, AP Calc students. Time for the second segment on Lesson 6.1. We're going to focus primarily in this lesson on these initial value problems and also learning a bit about how to use slope fields. That was that program that just got loaded on your calculator. How to use slope fields to verify solutions to those. Anyway, initial value problems are really nothing more than a specific case of finding antiderivatives, because what's going to happen here is we're going to be given the derivative and we're going to try to find what that original function is, and we're going to be able to really specifically find that function because they're going to give you a coordinate on that original function. So you'll be given something called a differential equation. So that's an equation that contains a derivative, as you might expect, and we'll be working with some differential equations, of course, in this chapter. You can get pretty sophisticated with this. There are whole courses, college courses, just in differential equations. But for our purposes, if you just remember that a differential equation, an equation that has a derivative. So let's take off and see what we can find here. All right, here's a pretty basic example for our first one here. We want to try to find the initial value. So they actually give us the derivative, dy over dx, is this 2x plus 1. And when they give you this particular notation here, y of 0 equals 3, when you see that, that means that actually when x, I'm going to change my pen width here, sorry about that, when x is 0, y is 3. That's what that notation means. That's a little bit confusing there, I think. Anyway, what we're going to do here basically then is we're going to take the integral of this 2x plus 1. I put the dx on there to show that it's an official integral. Notice we're not given any kind of lower or upper bounds here. This is an indefinite integral. But I could still figure out, I think, pretty nicely what it's going to be. I just apply the antiderivative to this. Again, my power has to be bigger, so I know it has to be something x squared, and the derivative of x squared is just 2x, so that's right. The antiderivative of 1 is just going to be plain old x, so that's right. And then don't forget, because I have this indefinite integral, I have to tack on this plus c value. So that is my original function here, but I'd like to more specifically find this c value, and I can do that because here I've been given one particular ordered pair, one x and one y, that's actually on the graph of this function. So I'm going to go ahead and substitute that in there. Basically what that means is I'm going to put in 3 for y, and in place of that x I am going to put in 0. And so I do that in a couple different places. It's going to be 0 squared plus 0 plus c. So if I simplify this a little bit, I think you see that I'm going to get 3 equals c. So therefore my final answer here, my specific equation, is going to be, I'll try to find a different color here to write this, about this one, is going to be y equals x squared plus x plus 3. So that's the initial value, the initial function that produces this particular differential equation right here. Notice that there are several actual functions that would give you this derivative. This is only one of them, but it is the specific one that satisfies both of these conditions. Now we want to take a look at this whole notion of slope fields. We'll talk much more about this in class, I think. I know you will. Anyway, you have this program that's on your calculator. There are several different kinds of slope field programs, but this one should do the trick, I think. So if you go to your program and go to slope field, you see this somewhat complicated menu here. The first thing we want to do is go ahead and enter this y prime right here, or again, another name for that is dy over dx. I'm going to just do the exact same problem I just did. So I put in that 2x plus 1, that was our previous problem here. And then I go back to my menu, and then I'm going to select number 3 here, which is to draw a new field. And I think in class we had you set this up so we're all pretty constant here anyway. I believe this is from -5 to 5 as far as the window goes. And look at that weird thing that it produces. We'll actually do an activity in class that will help us maybe understand this a little bit better. But basically these are various slopes at certain coordinates of this particular differential equation. Looks kind of bizarre. Alright, so anyway, so far so good. You should hopefully be able to get something that looks about like that on your calculator. Next, we're going to go back to that main menu, and we're going to go to number 4 here, where it says enter y. Keep in mind what we entered first was the derivative, or that differential equation. Now we'd like to enter y. Notice that's the exact same thing that we found. That's our initial value equation. One whose the derivative of this is this. This is the differential, or y prime, or dy over dx. This is just plain y. Notice I put in my specific +3 there as well. Then if you hit enter, it'll probably take you back to the main menu, and then you want to select number 5, which is to draw y. And that's what I showed here, I guess. And sure enough, it's the same slope field, but look at what is drawn. Now the y in this case, that's the original function. As you might guess, it would be a parabola because it does have something x squared. And sure enough, what you should be able to see here now is that as we look at this initial value equation, which was x squared plus x plus 3, notice how the slopes at various points do follow the original function. Looking right around here, clearly it's a positive slope. Here it's kind of leveling off a little bit. Here it's a negative slope. So in other words, it fits right in with that particular function. So that's one of the benefits of slope fields, is that it does help you figure out if you have actually calculated the correct initial value equation on problems such as this. Anyway, kind of weird stuff. We'll keep practicing it more in class, but that's the main thing I wanted to point out, how to solve those initial value problems using antiderivatives and then verifying your answer with these goofy things called slope fields. Alright, sounds good, gang. Thanks for watching, and we'll see you in class.